Okay, now so let's go into multiplication of matrices. Multiplication of matrices. There are two types of multiplication of matrices. Number one is scalar multiplication of a matrix. In scalar multiplication of a matrix is multiplied by a whole number, such as so this whole number now multiplies each element of this matrix individually. So now the resulting matrix from here becomes that's all for scalar multiplication of matrix. The other method of multiplying matrix is multiplication of a matrix by another matrix. That one is quite simple too. Matrix by another matrix. Just like the name implies, we are multiplying a matrix with another matrix. Like this matrix now. This is matrix A. Multiply matrix A with this. I asked to find A dot B and B dot A. In multiplying a matrix, this is the rule. The columns must be equals to the number of rows. This is the first matrix. This is the second matrix. The rule says that the number of columns on the first matrix must be equals to the number of columns on the second matrix. Like you can see here, the number of columns here is 2, 1, 2, and it is equal to the number of rows in the second matrix, matrix B now, 2, 2. So this matrices can multiply. If it were a 3 by 2 matrix, going with a 3 by 2, this is the number of columns on the first one, and this is the number of rows on the second one. These matrices cannot multiply because the columns and the rows are not equal, but a 2 by 3 can go with a 3 by 2 because the rows and the columns are equal. So now the resulting matrix here is going to be a 2 by 2. When the rows and columns meet, the resulting matrix now takes the form of the first column here. Sorry, the first row here and the other column here. So it becomes a 2 by 2 matrix. So let's look into A dot B. Now matrix A is simply this matrix here, 2, 6, 3, 2. Multiplying matrix B, 6, 1, 2, 1. When you are multiplying a matrix, remember you go with columns and rows. It goes like a 7. So this one's here multiplies this one multiplies this one. Then we add up everything we have there. Then this one again goes with this other one. This one goes with this now. This one goes with this one. Then we add up what we have. So what we are going to have is going to be 2.6 plus 6.2. And now 2.1 plus 6.1. Now the same thing happens down here. This one goes with this one, and then this one goes with this one, and this one goes again with this one. This one goes with this one. And remember to add up everything you have. So here goes 3 dots 6 plus 2 dot 2. Now 3 dot 1 plus 2 dot 1. So calculate that to get our answer. This is 12 plus 12, 24. This is 2 plus 6, that's 8. This is 18 plus 4, that's 22. Now this is 3 plus 2, that's just 5. So that's for A dot B. Let's write this answer somewhere up here. A dot B equals 24, 8, 22, 5. Now let's do B dot A. Now this is matrix B. This matrix now 6, 1, 2, 1 dot A 2, 6, 3, 2. Remember, the number of columns here is equal to the number of rows here. That's why this matrix can multiply. If it were 3 columns here and 2 rows here, they can't multiply each other. So the same thing happens again. 6 goes here and this one goes here. You add up this one. So now it's 6 dot 2 plus 1 dot 3. Then 6 dot 6 plus 1 dot 2. Now we do the same thing for down here. So one goes 2 dot 2 plus 1 dot 3. Now we go again. 2 dot 6 plus 1 dot 2. This is 12 plus 3. That's 12 plus 3, that's 15. 6 times 6 is 36 plus 2. That's 38. This is 4 plus 3. That's 7. This is 12 plus 2. That's 14. So we see this is B for A. You see now, the answer we had for A dot B is not equals to B dot A. That is showing us that multiplication of matrices is not commutative. That means A dot B is not equals to B dot A. Unlike in normal multiplication of whole numbers where 5 dot 2 is equal to 10 and 2 dot 5 is still 10. In matrices, it is not the same way. Now we are going to go into transpose of a matrix. Transpose of a matrix is very simple. It's just turning the rows and making them columns for the first row, the second row, and the third row. Now let's write transpose here. If you are given a matrix A now, let's say 6, 2, 3, 2, 1, 2, 3, 0, 0. Now we are asked to find the transpose of A. If you are to find the transpose of A, we are going to denote A with AT. This AT now means transpose of A. What we are going to do now is we are going to make this row a column. We are going to make this first row the first column. So this 6, 2, 3 is going to come up here, making it 6, 2, 3. This second row now is going to be the second column. So here is going to become 2, 1, 2. The third one here now too becomes 3, 0, 0. Just all for transpose of the matrix. No long. Now we are going into special matrices. I'm going to take only one special matrix because one is very important more than the others. Special matrices. Like you can see, every element of this matrix is 0 except for the elements on the diagonals. That's this element here. So, and the elements on the diagonals are 1, 1, 1. The rest of the elements are 0. We call this matrix a unit matrix. And it is said that any matrix, maybe matrix A, multiplying a unit matrix is still that same matrix. We are going to check if that law is correct. So let's try something. I'm going to take a 3 by 3 matrix and multiply it with a unit matrix and see if it's going to give us that 3 by 3 matrix. So now let's take a matrix. Let's take a matrix, 3 by 3 matrix. 2, 6, 1, 3, 2, 1. Multiplying a unit matrix. Now remember, during multiplication of matrix, this one goes with this one. That's how multiplication goes. So now 2 goes with 1, 6 goes with 0, and 1 goes with 0. So now what you are going to have is 2.1. Remember to sum up your multiplication. So go with 2.1, 6.0, 1.0. For the second line now, go 2.0, 6.1, and 1.0. For the third one now, go with 2.0 plus 6.0 plus 1.1. Let's go for the second column. Second column is 3.1 plus 2.0 plus 1.0. 3.0 plus 1 plus 2.1 plus 1.0. Third one, 3.0 plus 2.0 plus 1.1. Do the same thing over here. It's 6.1 plus 3.0 plus 2.0. 6.0 plus 3.1 plus 2.0. 6.0 plus 3.0 plus 2.1. So now I'm going to check to see if you are going to come back to this original matrix. Remember, 6.0 is 0, so here is going to cancel out, here is going to cancel out. You are left with 2.1. Here is going to cancel out, here is going to cancel out. You are going to cancel out, going to cancel out. So now we are left with 2, 6, 1, 3, 2, 1, 6, 3, 2. Like you can see now, we've come back to the original matrix. So this law is correct. That means any matrix multiplying a unit matrix goes back to the original matrix.